Welcome back to Open Data Technology Services. This video is a continuation of our custom Open Data API creation based on a flat file Open Data source. This walkthrough utilizes the pothole repair request data catalog for the city of San Diego, California. This exercise will consist of numerous steps to create our simple RESTful API that will respond beautiful JSON formatted data via HTTP request. In addition, this video relates to the conceptual animated video on our channel called API Development from File-Based Open Data Sets, the Whiteboard Overview. A pop-up of that video will occasionally display as we walk through each step of this exercise. Now let's summarize where we left off since the first part of this project. The objective of the last video was to locate the file-based data catalog from the open data source, then download the data file, import the data file contents into a database management system, and finally, explore the data using structured query language, also known as SQL. After the completion of the last exercise, we now have our file-based data in a database table to take our project to the next stage, which is creating a RESTful API for the San Diego pothole repair request dataset. From a high-level perspective, this exercise will consist of creating a RESTful API project, creating the code that allows our API project code to connect to the database we created in part 1, and developing simple queries in our API code that will respond with JSON formatted data. We begin by using our IDE to create a RESTful API project. Many modern IDEs allow you to create a sample RESTful API that includes the libraries and necessary template code to get you started. Once the API project is created, I always do a quick build and execute of the project on the development workstation to ensure everything runs as expected. I always like to ensure that we can connect to the database within the IDE. This helps to identify the connection string that will be important in the next portion of the exercise. After the database connection has been identified and tested, we need to install necessary libraries that will allow our API code to connect, query, and store data requests in our code's memory. The code libraries for this portion is for the object relational mapping modules of the code. There are many different flavors of ORM depending on the technology stack you're using for your project. Explore and choose which ORM library works for you. After libraries are installed, build and execute the project. Once the object relational mapping libraries are successfully installed in your project, we can generate the code that connects to the database as well as the additional ORM functionality such as querying the database. Our technology stack and tool allows us to perform an action called scaffolding that creates this project-related code via a command line that requires the database connection string and a project location where you want the code to be written to. In this exercise, our scaffolded ORM code will be written to a folder called Models in our code project. The DB context and model code is successfully generated. The next step is to create the API controller code that will be able to handle the Open Data API request through HTTP. The controller code will be added to the controller folder of our API project and initially only perform read and write actions. Once a new controller is added to the project, we will build, execute, and make a test call to our new API by specifying the API endpoint in our browser address bar. This exercise will create two API service method calls, one to retrieve 100 records and another to query and return only one record based on the index ID of the pothole request data record. Now that there is a fully functional API, the ORM code can be added to the API service method calls so that the data can retrieve via our program's code. Be sure to include the reference to the ORM code in your program so it could be utilized for this step. Next, add the code to connect to the database and retrieve 100 rows to be returned through our API request. Build, execute to ensure our code is working as expected. During this step, A breakpoint is added to the API method to ensure it is being hit by the execution thread. The debugger successfully executed our data request code and responding with nice JSON displayed in our browser. Finally, we add an API method that will take a parameter via the HTTP request and search our database with that parameter. In this example, the parameter will be the index of the pothole request in our dataset. Again, after the code is added, add a breakpoint, build, execute, and test the new API method we just created. As you can see, our new code is executed and one record is returned based on the parameter we passed. This concludes the API development portion of our project. Our next video will walk through the steps needed to operationalize our API by containerization and deploying to the cloud so it can be accessed via the internet. To reiterate, these steps can be utilized for most file-based data catalogs so you can further your data exploration skills and begin leveraging open data catalogs to serve your creative purposes. I hope this video was helpful to you and can promote some inspiration for creativeness and open data utilization.